In this video, I will show you how to conduct a paired t-test in R. You use a paired t-test when you have different flavors of the same variable. For example, maybe you want to know which type of ice cream tastes best. You could randomly assign participants to taste either strawberry or vanilla ice cream. Then you would conduct an independent samples t-test. But if you had participants taste both strawberry and vanilla ice cream, then you would conduct a paired samples t-test, because now you have two flavors of the same variable for every participant. For this example, we are first going to load the Haven, Tidyverse, and Psych packages, and then we will import the Harry Potter dataset and calculate the mean personality scores for each participant using the make or score items function of the Psych package. For our paired t-test, we will think of personality as our variable, and then different dimensions of the five-factor model as flavors. So we can conduct a paired t-test to examine whether participants have or differ across different flavors of personality. Because it is easier to type the variable names with the tidyverse, I'm going to start by piping dataset into the with command. The with command will then feed dataset into the t-test function. And then it's much easier to just type the variable names rather than have to type the data frame that they belong to, put a $sign, and then type the variable names. So let's use agreeableness and neuroticism as our flavors of personality. And then after we've typed in the variables we want to include in our t-test, we just tell the t.test function that we want to conduct a paired t-test by adding the parameter paired and setting it to true. And when we run that code, we get this nice output down here. We can see our t-value, we can see our degrees of freedom, and we can see our p-value, which is much, much lower than 0.05. So participants really do differ in terms of their agreeableness and their neuroticism. Now, it's also possible to conduct a directional test. And we do that by adding the alternative parameter. So let's say I predicted that agreeableness would be, people would score lower on agreeableness than they would in neuroticism. Then I would set alternative to less. And now you can see the p-value is, it's so high it's been rounded up to 1 by R. And so it's really not the case that participants score lower on agreeableness than on neuroticism. On the other hand, if I were to predict that participants would score higher on agreeableness or greater on agreeableness than neuroticism, I just change alternative to greater. And now we can see that the p-value is very, very small. And so again, there's sort of, we would be able to conclude that their agreeableness, participants are scoring higher on agreeableness than on neuroticism.